Nowadays, there's an increasing necessity to optimize the integration of renewable energy sources and new consumer energy needs. The main goal of i3Res is to develop a management tool for the distribution grid. A large number of customers and companies are starting to produce their own energy. The latest International Energy Agency (IEA) report shows that the photovoltaic production, as well as the need for required knowledge concerning solar and battery energy, has dramatically increased all over the world. Monitoring and control solutions especially designed for distributed energy sources are being developed, but many of these systems do not utilize the information sources from other systems in the backbone grid. The interoperability between systems becomes even more important with an increased amount of users and available data. New consumer energy needs, such as the use of electric vehicles and induction cooktops, are challenging the DSO companies. Ensuring consumers an unlimited amount of power will represent too high investments for the DSO, costs that will be reflected in the bill of the customer. At the same time, more and more customers, both end users and companies, are starting to produce their own energy and feeding the excess power back to the grid. Naturally, the feed into the grid will then depend on everyday energy usage of the building. Solar and wind energy needs to be consumed immediately. If the energy usage in a building is high, for example whilst charging electric cars, heating the rooms, preparing food, and at the same time the production from the RES is at its peak, less energy is being fed by the DSO's grid. Now, imagine the same building with the same or higher consumption, but with no RES production, for example, night and no wind. The customer will need to rely on energy supplied by the DSO's grid. However, the DSO's capacity might be limited in certain areas of the grid, making the grid unable to supply the energy requested. Unregulated power and new consumer needs will create challenges both for the DSO and the end user. Low impedance and overvoltage could negatively impact the grid's stable operations of transformers on one side and consumers' appliances on the other. For the DSO, the security of supply will be threatened and the customer's needs may not be fulfilled. How do we solve this problem of imbalance? One way is to install measurements on several places in the grid, measuring the state of the grid. Upon receiving these measurements, an operations central will perform actions based on the state. From the DSO's operations central, it will be possible to calculate optimal power flow and indirectly or directly control the customer loads through an aggregator service. During the day when the consumption is low, but where the production is high, the energy could be stored in a battery, providing the household or building with energy later in the day when PV production is low or the use of power is high. If the consumption is too high in an area where the energy production is low, the local grid company could activate the aggregator contract and make sure the aggregator cuts the necessary amount of load in the houses. The partners in i3Res have tried to face the imbalance challenges in the grid by developing a monitoring and control platform. i3Res management tool aims at balancing the energy production and energy consumption curves in an optimized and controlled way by providing updated and detailed information of the grid's distribution, operation, and state. Single sign-on and unified user interface is the access point for the three i3Res users, DSO, aggregator, and customer, to the i3Res smart tools. The heterogeneous application with unified design makes the user able to access only the pages and tools. Each application might have one or more databases to store data locally. Applications communicate to lower layers via the semantic middleware layer. Semantic middleware is the core of the i3Res management tool. The application developers can use the high-level service endpoints to seamlessly interact with the devices or entitles the lower layers such as real-time database, sensors, and actuators. Through the communication broker and services, the monitoring infrastructure, real-time database, diagnostic system manager assure the middleware and thus the applications is able to communicate with the appropriate sensors and actuators at the lower level. In the local monitoring and control layer, the monitoring infrastructure, actuators and sensors are located. They are distributed geographically, produce data and/or receive commands from the layers above. The validation of the results developed in i3Res have been done in two phases, in Steinkjer in Norway and one in Teknalia Lab. In the first phase in demo Steinkjer, installations of sensors and monitoring infrastructure was done. Based on the needs of the i3Res partners, several instruments were installed whilst other instruments were already available in the lab. In order to obtain meter readings from electrical meters available in the living lab, Demo Steinkjer NTE has developed an API which is integrated into 3i3Res middleware and used by applications such as the aggregator service. The data is available following the CIM standard. There are approximately 800 unique power meters behind the API. Another important instrument installed in i3Res is the Phase Monitoring Unit, PMU. These PMUs are measuring phase voltage, current and frequency. The integration to i3Res middleware is done by Apache Camel. The PMU data is used in order to reduce losses and to calculate optimal power flow. Other measurement instruments, both in the secondary substations and in the households, are installed. The data is then being used in order to validate long-time running data, gathering functionalities and applications such as the forecast service. After the second period review in the project, the partners worked together to find the best solutions to validate products in Technalia Lab and in the Living Lab in Steinkjer with real customers. There are some aspects that either are not possible to validate in the Living Lab, or that, due to safety reasons, are better to validate in a controllable environment. Technalia's microgrid laboratory provides an environment in which energy devices can be tested in a controllable way. It comprises the DER devices with a total available generation capacity of 100 kilowatts and a total consumption of 190 kilowatts. In addition to Technalia's laboratory, Inabensa's facilities have also been used for those tests that do not require a microgrid laboratory. In the second phase, parts of the i3Res developments were tested either directly in Demo Steinkjer or by using data from Demo Steinkjer. The optimal power flow was tested at the power plants in Demo Steinkjer, with all the necessary measurements installed being able to provide accurate and real-time data. The smart grid supervision process and aggregator service was demonstrated and validated using real customers, important stakeholders, and power supply companies in workshops in Norway. Finally, several experts from the DSO and the power supply company went through the project results systematically, providing feedback, suggestions for improvements, and valuable information for the exploitation of the products entering into the Norwegian market.
As CIO in NT, I'm responsible for evaluation of the system portfolio and the ICT architecture. Digital value chains and digital operations are key elements of the future energy companies. Yet, digitalization is not easy to achieve when solutions are information silos and are not interoperable. The i3Res middleware, which uses a common information model and which are built by using cost-effective, open source solutions, try to solve this challenge. The i3Res middleware has become an extensive platform for implementing new tools and new technologies. At NTE, we are now implementing NoSQL databases for high-speed retrieval of data and new analytic tools for cross-domain data crawling. i3Res middleware could be one of the resources we need to achieve our goals. The project has been very important for NTE in order to get extensive expertise that enables us to take the right choices for our future ICT architecture. When the i3Res concept is fully matured, i3Res could play a vital role in the industry as a platform for implementation of new value chains within the smart grid domain.
When the project started 3 years ago, business models arising from the smart grid domain were quite immature. The reason for this was probably that the two disciplines to contribute, energy and ICT, lack knowledge about the other domain. This is something that the partners in i3Res has invested quite a lot into, since the project merges partners from the two different domains. This knowledge has resulted in new products, services and projects that are possible to exploit further, and this will lead to new opportunities for all the partners in the project.